Hello everyone and welcome to Implicit Differentiation. So, what you are seeing here is number 14 from the review worksheet for 2.6, 2.8. I thought it was the tougher implicit differentiation problem that I put on their review. It involves a few things that I think are, interesting. If you could do this problem, basically you could do any problem. So let's begin. What is implicit differentiation? Okay, implicit differentiation is basically differentiating variables in terms of a variable. We've always been taking the derivative of functions that were like this, where we're 3x minus 5 or something like that, and we take the derivative of that. That's explicit because we know we have one variable in terms of the other. Implicit is when there's variables, I guess, combined, if you will. There's x's with y's and all that good stuff. And basically what I'm going to tell you is the directions are going to say find dy dx, so solve for dy dx. We need to take the derivative of this function in terms of x, and which means we have some y's, which causes some problems. So let's just begin, and I'll explain as we go. So the first thing we have here is 7x cubed. When you take the derivative of this, now you're taking it in terms of x, so you can just do business as usual. That's just 21x squared. Okay, that's simple. The next term is negative 4y squared. So again, you as I said in class, you basically are pretending that this is an x. You take the derivative as if you were taking any derivative. Okay? But then because it's a y and not an x, you have to account for that. So what you do is you use this dy over dx term. That basically is telling everyone, you're basically doing the chain rule and taking the derivative of this. First you take the derivative of your f of x and then times your g of x, and this is essentially what's happening. I like to think of it as we're differentiating y, we're pretending like it's x, and then this gets us out of that pretend, and this is accounting for the fact that it's a y instead of an x. Alright, in the next term, you have negative xy. Alright, I'm going to kind of come over here, I'm going to draw a big line down the page. This line is going to break up the side work that I have, because this is actually a product rule. When you have negative xy, you have a product of two functions. The one function is negative x, the second function is positive y. Alright, now you have to take the derivative of both of these, because as we know, the product rule, if you watch the other video or been in class or whatever, the product rule is f prime times g of x, excuse the handwriting, plus, oops, I put g prime, my fault, error, be quiet, Austin. Alright, g of x, I'm just kidding, then g prime times f of x. Alright, so we need all these things, so let's take the derivative of each thing. Now remember, we're differentiating in terms of x, so when we take the derivative of negative x, we get negative 1. When we take the derivative of y, we get 1, but then because it's a y, we have to account for that by using dy dx. Alright, so you plug these into our little product rule here. Negative 1 times y plus g prime, which is dy dx, times negative x. Alright, I'm going to just rewrite this a little bit differently. Negative 1 times y is just negative y, and then this I'm going to write it as negative x dy dx. Okay? So that's the derivative of negative xy, so I plug that in over here. Dy dx. Okay? Then I'm going to delete that information over here so I can use it for the next guy. Delete. Alright, the next guy over here is 5x squared y squared. So again, product rule. Alright, so we identify our pieces. 5x squared, g of x, y squared. We take the derivative of each piece, x, 2y dy dx. Sorry, it's getting scrunched in there. So we need to write out our derivative. So it's f prime times g, so we get 10 xy squared plus 2y times 5x squared is 10x squared y dy dx. So we put this over here, plus 10xy squared plus 10x squared y dy dx equals, and derivative of a constant, no matter what you're differentiating, is always 0. Now, implicit differentiation rule number 2. Factor all, get all of the dy dx's on one side of the equal sign and get everything else away from it. So, I think you guys are, advanced enough to see that we get dx minus x dy dx plus 10x squared y dy dx equals, subtracting everything, negative 21x squared plus y minus 10xy squared. If you don't see that, I move this term over, I move this term over, and I move this term over. So now we need to factor out a dy dx because it's in each of these terms. So we got it's a d dy dx times what's left, negative 8y minus x plus 10x squared y equals, hand hurts, negative 21x squared plus y minus 10xy squared. Alright, then you divide both sides by the term that is with your dy dx. So dy dx equals negative 21x squared plus y minus 10x y squared divided by negative 8y minus x plus 10x squared y. Done. Bam. Alright. The next step usually would be to just make sure that you can't simplify or can simplify or whatever the case may be. Just make sure that you're done. If you look at this, everything is as factored as possible. You're not going to be able to cancel anything from the denominator, the numerator, or factor anything out of either term. So this is actually your solution. It's messy, but that's the solution, and that's everything. That's implicit differentiation. Basically, any problem you see, whether it has product rule in it, quotient rule in it, chain rule in it, whatever, all right, you take the derivative of everything as if it were an x. If it isn't an x, you have to account for it by using this dy dx. All right, do the rules as usual, whether it's product rule, quotient rule, chain rule. Just follow those. I always do them on the side. You know that. You've seen me in class. Then put them back into the original equation. Bring all of your dy dx's on one side of the equal sign, everything else on the other side of the equal sign. Factor out your dy dx. You're going to get a term. Divide it. Divide everything by that term, and booyah. Boom. That's it. All right. I hope this helps. If you have any other questions, please use the website, and or come see me in class. All right. Thank you very much for watching, and again, have a great time studying. Good luck. Bye.